Today, we're diving into some really cool new technology. It's designed not just to fight a war that's happening inside our own bodies, but to actually try and negotiate a peace treaty. We're talking about retraining our immune system, teaching it to stand down in the battle against autoimmune disease. So let's get right into it.
I mean, just think about that question for a second. How do you stop a war inside your own body? For millions of people who live with autoimmune diseases like rheumatoid arthritis, this isn't some metaphor. It's their day-to-day reality. A painful, constant battle where their own defense system has gone rogue.
So, to really understand the breakthrough we're going to talk about, first, we need to wrap our heads around the big puzzle of rheumatoid arthritis, or RA. It's a devastating and, honestly, a textbook case of friendly fire. So what is rheumatoid arthritis? Well, imagine your immune system is your body's personal security force, right? In RA, that security force gets totally confused. It starts seeing your own healthy joint tissue as some kind of foreign enemy and just, bombf, launches a full-on attack. This assault is what causes all that chronic inflammation, the intense pain, and, over time, the destruction of the joint itself. And even with all the medicines we have today, researchers point to two huge unsolved problems. First, how do you stop the disease from even starting in people you know are at high risk? And second, for people who already have it, how do you stop those sudden, awful attacks we call flares? Right, and this is where it gets really interesting, because it shows how our current toolkit is, well, it's imperfect. To fight those flares, we use broad suppressants like corticosteroids, but they're kind of like a blunt instrument. Think of it as using a sledgehammer to crack a nut. Sure, it works, but you cause a lot of collateral damage, all those side effects. And on the other side, for prevention, we have drugs that can delay the war, but for most people, they don't stop it from eventually breaking out. But what if you could be more precise? What if, instead of just carpet bombing the whole system, you could go straight to the top and retrain the immune system's generals? And that brings us to the hero of our story today, a tiny nanoparticle designed to be a peacekeeper. So, let's meet Agg-CLNP. It's a bit of a mouthful, but this tiny particle was developed by an amazing team from UC San Diego, Cedars-Sinai, and the University of Gothenburg. And its entire mission is to act like a special envoy, delivering a new, peaceful set of orders directly to those confused immune cells that are leading the charge. And this is where the design gets just absolutely brilliant. Think of it like a 4-step stealth mission. First, you build the vehicle. It's a tiny little sphere that just dissolves, kind of like stitches. Step 2, you load the cargo. Inside is a peace treaty made of calcitriol that's a form of vitamin D3 that sends out calming signals. Step 3, you program the GPS. The outside is coated with a special molecule that guides it only to the immune system's generals. These are called dendritic cells. And finally, step 4, the mission. These generals swallow the nanoparticle, read the new orders inside, and learn to call off the friendly fire. It's so clever. Okay, so the design is incredibly smart, but here's the billion-dollar question, right? Does it actually work? Let's get to the results, starting with that first huge challenge: can it stop the war before it even begins? The data from the preclinical models is just striking. Take a look at this chart. It's showing the severity of arthritis in mice. That first bar, that's what happens when you use a standard preventative drug by itself. I mean, it helps a little, but there's still a moderate level of disease. But now look at that second bar. That's when they added the Agg-CLNP nanoparticle. The disease severity just plummets. It's a night and day difference. This is what scientists get really excited about. It's called a synergistic partnership. It's not just 1 + 1 = 2. This is more like 1 + 1 = 5. The nanoparticle peacekeeper didn't just add its own benefit. It actually supercharged the existing drug. It made the whole combination way more powerful at preventing the disease and dialing back the severity. Okay, so that is a huge win for prevention. But what about that second critical problem? Can this nanoparticle help control those awful, unpredictable flare-ups in someone who's already in the middle of the fight? So here's another key experiment. That first bar shows what usually happens when a patient stops taking strong steroids. The disease comes roaring back, a really severe flare. But look at the second bar. In this group, after the steroids were done, the researchers gave them the Agg-CLNP nanoparticle. And the result? The returning flare was just a shadow of its former self. It was dramatically reduced. So what this really tells us is that the nanoparticle helps maintain the peace.
The steroids force a temporary ceasefire, right? And then Agg-CLNP comes in right behind them to convince the generals to make that ceasefire last. It keeps them in a calmer, more tolerant state so they don't immediately start launching another attack. And you don't have to take my word for it. The researchers themselves, in their paper published in the journal ACS Central Science, put it perfectly. They say that these findings show that Agg-CLNP is a real potential strategy to tackle the biggest unsolved problems in treating RA. So let's just step back and look at the big picture here. Because what we're really seeing is something more than just a new, better drug. It's a completely different way of thinking. It's a fundamental shift in strategy. This slide just captures it perfectly. The old way was broad immune suppression. It's like a fire hose that puts out the fire, yeah, but it also floods the entire house, causing all sorts of side effects and leaving you vulnerable to real infections. The new way is targeted immune retraining. It's like a special forces unit on a stealth mission, sneaking in to deliver new orders only to the rogue cells. The rest of your immune army is left completely intact, ready to fight off the real bad guys. So let's just quickly recap the big takeaways. We have a new nanoparticle that can actually retrain specific immune cells, not just shut them down. It makes existing drugs work way better at preventing the disease. It helps control those awful flares after treatment ends. And maybe most importantly, because it's so targeted, it could mean a future with far fewer of those debilitating system-wide side effects.
And that, of course, leaves us with one last, really profound question. If we can use this peacekeeper approach to retrain the immune system for rheumatoid arthritis, what's next? Could this be the blueprint for how we fight other autoimmune diseases like MS, lupus, or type 1 diabetes? It is an incredibly hopeful look at what could be a whole new era of medicine.